Hello, I'm Richard Jack, and I'm going to take some time today to talk through thermal performance measurement and the work we've been doing on that with Build Test Solutions. So I wanted to start off with something pretty fundamental, which is why should we measure at all? And I'm not going to talk to a really informed group like this in detail about the performance gap, but I just wanted to highlight that we've done a lot of measurements all around the world, and they've all shown that it's common for there to be a difference between the predicted and measured performance of buildings. So those small samples of building performance measurement have demonstrated that if we want to manage and control energy use in buildings, we're going to need to know more about them because at the moment we don't really have a good idea of how well they perform. The first tool that I'd like to talk about is Smart HTC. So this is a tool to measure the overall thermal performance of buildings. I think of it as the best overall barometer for whether a building is performing as you expect. So an HTC is a heat transfer coefficient, and that is a rate of heat loss from inside to outside by all methods. So that covers fabric, infiltration, and ventilation. And the measured HTC can be directly compared with the predicted HTC, and the HTC will be predicted in pretty much any energy performance assessment. So most common would be EPCs or PHPP assessments, for example. So what you have to do for a smart HTC measurement, you need 21 days of internal temperature and energy consumption monitoring collected when the temperature is at least 7 degrees warmer inside than outside. And we're going to take that data and use it in our cloud-based Smart HTC calculator to account for the weather during the monitoring period, any occupant behavior, appliance use, hot water heating, space heating. We're going to account for all of that in the cloud-based algorithm and return just this HTC measurement. So it's the thermal performance of the building only. And the key development of Smart HTC is it can be carried out while a building is occupied as normal. So it gets rid of previous restrictions around buildings having to be empty while the test is carried out. The occupant can just stay in the house and use it as normal. There's two ways to apply a Smart HTC measurements. The simplest to think of would be like an on-site measurement service. So a surveyor would go to a house, install temperature sensors, take some details of the building, leave the sensors in place for a period of at least 3 weeks, can be longer, and then go and collect those sensors, take that data, upload it to the calculator, and get the HTC measurement back. And then there's another, perhaps more exciting and scalable way we could do this, which is that houses already have a lot of monitoring technology in place. If you think about smart meters, smart thermostats, smart devices, there's energy consumption measurements and internal temperature consumption measurement going on all of the time. So instead of installing new equipment and all that hardware cost, we can add value to the data that's already being collected. And the Smart HTC calculation can be integrated into those platforms via APIs, so we can automate the transfer of data into the calculator and the return of the measurement and present that through the systems that are already in place. One of the key roles we think in BTS is to provide the confidence that the tools that we provide work accurately. So for any new product that we introduce, we'll put a lot of effort into validating the results. And Smart HTC is no different. So as part of our validation process for Smart HTC, we did more than 300 Smart HTC measurements in more than 200 dwellings. And in 42 of those, we compared the Smart HTC results with the results of a co-heating baseline test. So co-heating is, has been the industry standard method to measure heat transfer coefficients, but they're pretty expensive and invasive. We're looking at vacating a house for a period of 2 weeks and a cost of several £1,000s, and that's limited, I think, the total number of co-heating tests to be in the low hundreds. So that makes this comparison of 42 versus Smart HTC one of the biggest comparison data sets that's been developed, I think. As well as our own comparisons, we've had third-party blind testing through the SMETA project, and those results will be presented as part of this conference. and we've had an open book review of the algorithm and all of our data by the University of Salford. And across that sample of buildings, of 42 buildings, you can see that chart on the bottom right, we've had quite a range of building performance. So those 3 small towers on the right are passive house flats. So that's one of the most tricky places you could measure heat transfer because there's so little heat being transferred. But we've had really consistently good agreement between co-heating results and smart HTC results across the building. And that demonstrates accuracy. So we've had more than 99% of our smart HTC samples have agreed with a co-heating baseline measurement. We've also, in the same building, looked at the repeatability of a smart HTC measurement. So if I measure in November, will I get the same result if I go back and measure in February? So we've broken up larger samples into smaller subsamples and found a repeatability and RPD of less than 1%. So that's saying that the measurement in the same building is very similar every time. So now we have this new tool in the toolbox. What can we do with performance measurements? So I want to take you through a few examples of applications of HTC measurement. So here's a really interesting example. It's a social housing provider doing HTC measurements across their stock through a measurement service visiting these buildings, and then they can use those HTC measurements to target buildings which are particularly low performance and get most bang for their buck from their retrofit spending to reduce energy, cost, and carbon, and also to help people who are particularly at risk of fuel poverty because their thermal performance is poor. And they can also start to target buildings. Buildings with particularly low thermal performance are likely to encounter other issues. So perhaps mold growth could be more of an issue if you have extra high heat loss. And problems like that cause complaints and they cause reactive maintenance costs, which are particularly problematic for social housing providers. So by targeting buildings which are particularly poorly performing and improving them before the issues occur can reduce those expensive reactive maintenance costs. An interesting thing as well is that if you're looking to do a retrofit, it helps a lot to know what the building's like before you start. If the thermal performance of the wall is not as you expect, then the design for the insulation that you put on top should be different to make sure that you get the U value you want at the end and to avoid risks associated with interstitial condensation. So we're using those performance measurements as an input to design, and then finally post-works we can use them for quality assurance to find out if there's any faults in the works that have been applied. Here's another example that takes advantage of the scalability I mentioned earlier by integrating with existing devices. So this is an energy company seeking to provide better advice to their customers. So by integrating with an in-home display, which provides both the internal temperature and energy consumption measurement, the energy company is able to very inexpensively carry out thermal performance measurements on a really high number of buildings. So if you think about the number of buildings which have these devices in already, we're talking about a really exciting level of scalability. So the energy company is then able to provide their customers with tailored recommendations for things that they could do for their building, enabling more informed retrofit decisions across a really wide stock of buildings. So it's quite an exciting way to think about really scaling up performance measurements which have previously been in quite low samples. I wanted to finish off by talking about a second product, which is Heat3D. So I said earlier that Smart HTC is a good overall barometer of whether your building performs as you expect. But what if it doesn't perform as you expect? Then we're talking about building diagnostics to try and figure out why there is a difference between the predicted and actual performance of a building. So Heat3D is a tool to do that, to measure the thermal performance of your walls, to see if there's a difference between the design expectation and the reality. It's a patented iOS app that uses a plug-in FLIR-1 infrared camera to make 3D infrared models of rooms with quantified U values across the whole surface, and these U value measurements can be taken in an hour. So that's quite a big step forward from existing methods like heat flux plates, which would measure U values in one specific location and would require being in place for at least 3 days. As with Smart HTC, we spent a lot of time and effort validating the accuracy of the results from Heat3D. So that's included 500 comparisons of the measurements of heat flux by Heat3D and heat flux plates, showing really close agreement with more than 90% of the measurements agreeing with each other. And we've also done 14 comparisons with U values measured by the industry standard ISO 9869 method using heat flux plates. So if you look at the chart in the bottom right there, you can see we've had really close agreement in U value measurements by Heat3D and ISO 9869. So really promising results there. And that's across a wide range of thermal performance, ranging from very well insulated to quite poorly insulated walls. And we've also had a third-party review by the National Physics Laboratory of the underlying mechanics and physics of Heat3D. So that's another tool that we're bringing to the bag to allow performance measurement to become more mainstream. Thanks for your time today and joining me on a whistle-stop tour through building performance measurement. I hope you can all see that there's a lot of value and now a lot more accessible tools to be doing building performance measurement on a much wider scale.